So we can do a hypothesis test for that. So here we're going to define mu sub d like here. Okay, so we can just simply copy that down here. Mu sub d is defined in that fashion. Now we want to test whether there is a difference. So the hypothesis is mu sub d is equal to 0 against mu sub d not equal to 0. Let's assume 5% for alpha. Then the t value is d bar, our sample mean, minus the hypothesized mean divided by the standard error, which is over here. Degrees of freedom is n minus 1. Okay. Now we can do the testing either based on the table value or based on p-value. We'll do both. So t table value is t dot inv, and this is a two-tailed test, not equal to. So alpha and degrees of freedom will give us the t table value, and since our calculated t value is less than t table value, we cannot reject. We should say we do not reject the number. Now p value is given by t dot dist. Okay, now we use the 2t function. Okay, then we give the t calculated t value and the degrees of freedom. Remember the dot 2t function, this will have to be, this cannot be negative value. So it is always a good idea to make it a practice to put absolute value for the t even when it is positive. So that way you know that you get to the habit of using absolute value. So now since the p value is greater than alpha, then we cannot reject the null hypothesis. So now we can say we do not reject the null hypothesis. We do not have sufficient evidence to reject the null hypothesis. And if we did reject the null hypothesis, then the probability of type 1 error will be 7.95%. So that will be our interpretation. So we do not have sufficient evidence, and the type 1 error is 7.95%.